Now we're continuing this problem on the charged infinite sheet with a circular hole in it. And remember that in part A, we have solved for the electric field at a point P, a distance delta from the center on the minus z axis. So we found it sigma delta over 2 epsilon 0 square root delta square plus r square in minus k hat direction. And we have a negatively charged particle here. This will feel a force in the upwards direction. On the other hand, we solve for the maximum mass this particle can have for it not to fall indefinitely. In part C of the problem, if m is less than m max, how much work is done by the electric field as the particle drops from z equals 0 to z equals minus delta? And in part D, in the same interval, how much work is done by gravity? Okay, so first of all, I know that the electrical force points up for the negatively charged particle. The displacement is downward. So force and displacement are in opposite directions. So work done by the electrical force has to be negative. Now, what is the work done by the electrical force? It's the integral from z equals 0 to z equals minus delta electrical force dotted with displacement, and this is going to be integral from 0 to minus delta. For the electrical force, we will substitute the electric field multiplied by the charge sigma zq over 2 epsilon 0 z square plus r square square root. This is our electrical force. And now this work has to be negative, so we have a minus sign here, minus sign dz. So we're going to integrate this. And this will give us minus sigma q over 2 epsilon 0 integral from 0 to minus delta z dz divided by square root of z square plus r square. And if we let z square plus r square equal to u square, we see that 2z dz becomes 2u du, and u is equal to square root of z square plus r square. So this gives us minus sigma q over 2 epsilon 0 integral from 0 to minus delta u du divided by u. So u's will cancel, and I'm left with this is from z equals 0 to z equals minus delta. So integral of du is just u minus sigma q over epsilon 0 u, which is square root of z square plus r square that will be evaluated between 0 and minus delta. And this gives me an electrical work minus sigma q over 2 epsilon 0 square root of delta square plus r square minus r. So I substitute z equals 0 and z equals minus delta. So it's square root of delta square plus r square minus r. That's the work done by the electrical force. Now in part D, we're supposed to find the work done by the gravitational force. This time we have Wg equal to integral from 0 to minus delta the gravitational force dot product with displacement. Gravitational force is parallel to the displacement. Therefore, the work done by the gravitational force has to be positive. So we find that this should be equal to mg, the gravitational force, multiplied by the displacement mg delta. So the work done by the gravitational force will be positive. It's a constant force, so we're just basically multiplying the force with the displacement and noting that they're in the same direction, so the work done by the gravitational force has to be positive. Okay, so we looked at the work done by these two forces as the particle falls down. So first we do from 0 to minus delta dot product electric field with displacement. And this work has to come out negative because they're in opposite directions. So I put a minus sign here. It is minus sigma 0 q dz over 2 epsilon 0 squared z squared plus r squared. And for this one, z squared plus r squared is equal to u squared, and 2u du is 2z dz, so u is square root of z squared plus r squared. We see that this is u du divided by u, which gives us integral of du, which is u. So minus sigma q over 2 epsilon 0 square root of z squared plus r squared, evaluated between 0 and minus delta, and that gives us minus sigma q over 2 epsilon 0 square root delta squared plus r squared minus r. It's a negative work. Work done by the gravitational force will come out positive. It's the integral from 0 to minus delta gravitational force dot product with displacement. Because the gravitational force and displacement are parallel to each other, it has to be positive. It's a constant force that comes out of this integral. So we have mg times delta, the positive work done by the gravitational force.